Alrighty, it's 1, so we'll begin the webinar. Good afternoon. On behalf of KUKA Robotics, we'd like to thank you all for joining today's webinar, Power Up with KUKA KRC5 Controller webinar. Allow me to introduce today's presenter, Mike Chafee, our Senior Sales SAE. All attendees are muted for this webinar, so if you have any questions, please type them in the questions section, and I will ask them on your behalf. Mike will pause periodically to answer questions, and a link to the webinar video will be emailed to everyone in about 2 weeks. And this is a live recording, and it will be on our website and on YouTube. So I'll now hand it over to Mike, the presenter. Thank you.
Thanks, Austin. Yeah, my name is Mike Chafee, sales application with KUKA. And like Austin said, if you have questions throughout this, just type them in and we will try to answer them periodically. All right, so today's topic is the KRC5 controllers and cabinets, some of the safety options that go along with those. Specifically, we'll be covering these different subtopics, the cabinet versus the controller, different models of KRC5, robots that are compatible, with which controller, power in feed. We'll be talking briefly about multi-robot cabinets, some of the environmental characteristics, also external axes, custom kinematics, custom robots, UL, and then finally some of the options that are available with the cabinets and the safety options. So to start, with KRC5, KUKA makes a distinction between the cabinet and the controller. So the cabinet is the big box. It's the IP-rated enclosure that the robot controller goes into, as well as some other components. So this the cabinet does have functionality. It provides the 3-phase power in-feed components, so terminal block, main power switch, power filter, things like that. So it handles the incoming power. It also has the UPS batteries and ballast resistors for dissipating excess robot energy. So there's some functionality that the cabinet brings, but for the most part, it's an enclosure. The robot controller or controller module is smaller. It's pictured here on the right, and it provides all the functionality for the robot. So that's where all the motion planning is done. It's got the computer, does the I/O, HMI. The controller module also has the servo drives inside of it. It's got the safety system, and then some space for optional safe I/O and non-safe I/O boards. So this is the robot controller module, and it's this is all based on the KRC5 standard, what we call. So the cabinet standalone, the robot controller standalone are not really useful. They need each other. So the robot controller module takes up a space inside the cabinet, and there are a couple other things that can go in the cabinet. One would be an additional axis module. So this is for additional external axes, and this looks identical to the robot controller. The insides are a little different, but it does have the same size and form factor. The other thing that can be put into the cabinet is the device plate. So it's basically a tray with some peripheral components, things like 24-volt power supply, additional I/O, network switches, things like that can be put on there. And that would also take up a space inside the KRC5 cabinet. So that was all the KRC5 standard. The other smaller version of the controller is the KRC5 Micro. So this is much smaller, about the size of a desktop PC. And it's a little bit different because it does not need a cabinet to be fully functional. So the KRC5 microcontroller includes all the same things that the standard size robot controller module does. In addition, it handles its own power in feed, its own energy dissipation. So it's got all that built into it. The only thing that is separate is the UPS battery box. So the microcontroller can function by itself. We do have a micro cabinet option, and we will talk about that. Okay, so let's look at the different models of KRC5. So just looking at the KRC5 standard, there are 4 different sizes of cabinet. Starting from the left, we've got the basic, and then dual, triple, and quad cabs. And these are just based on the number of spaces inside them. So one module occupies one space. The robot controller is a module. The external access drive box is a module. So it's just how much room is inside the cabinet. And looking at the dual, triple, and quad cabs, they're all the same width and depth, so they only vary in height. The basic cab, which is new and coming out this fall, it's a little bit smaller in width and height, but it's big differences in the depth. It's about 2/3 the size when we're talking about the depth. So it's a little different form factor, but great for tight spaces. So all the cabinets shown here have a standard cabinet base. That's these little gray feet basically at the bottom. And those are, those contribute 100 millimeters to the height of the cabinet. So those are optional. So if you wanted fork slots instead of standard cabinet base, those would be a little bit shorter. You can also get rollers and transformers. So all of those options would contribute to the height of the cabinet. Since the basic cabinet is new, just a closer look inside it. One of the big differences between it and the dual, triple, quad are that it has just one front door, just the only a front door. The dual, triple, and quad have a side door, so this right side door would open as well. The basic cab doesn't need that. It has a slightly different cable inlet, so all the connection cables come in the back so that you can connect them to the robot controller. And you can access those through the front door. One option that this basic cab has is what we call a rear heat sink, so some additional cooling on the back, and that's needed if you need to put this cabinet right up tight to a wall or right up tight, side to side with other equipment, then that heat sink would be needed. If you've got some space that would meet the minimum space requirements for cooling, then you wouldn't need that option. One other note, if you deal globally, is there are a North American version and a European version of this cabinet. So there are a few differences. So just wanted to note those. So with the North American version, the main power switch is interlocked with the door, so you can't open the door with the power on unless you have a special tool. Likewise, the side door on the KRC5 standard is interlocked with the front door. So basically you have to have both doors closed before you can turn power onto the cabinet. European requirements don't need that, so they don't have that. And then the North American cabinet also has additional surge suppression. Looking at the models for the KRC5 Micro, we've got the controller only. We talked about that. We do have a 19-inch rack mount tray. So if you want to put it in a rack, you can. One thing to note with that is that the connectors, the cables and the connectors come out the front here. So you do need some space to connect and route those cables. And then relatively new is the KRC5 Micro cabinet, which is gives you some dust protection. The microcontroller by itself is rated at IP20, whereas the cabinet is IP54. Looking inside the cabinet, there are 2 spaces. So space for one micro robot controller and space for an additional drive box. as well as some space for peripherals, 24 volts, etc. And just two things to note. So you cannot use the micro cabinet as a multi-robot cabinet, meaning you would not be able to put two micro robot controllers in here. The space, from a space perspective, there's enough, but from a cooling perspective, it's not adequate. So one robot controller, you can control external axes like a positioner or a linear track, but not two robot controllers. The other thing to keep in mind is that the microcontroller that goes in here has some modifications to work with the cabinet. So there's a fan that's used for cooling inside the cabinet, and that fan needs to have control, and that control is added to the microcontroller that goes inside this cabinet. So if you, where this would be important is if you have a microcontroller already and you decide, hey, I'd like to stick that in a cabinet, you can't just put it in there and have it work, because that microcontroller wouldn't have the circuitry to control the fan. So that would have to be retrofitted, and there's a kit forthcoming for that. Okay, we'll go through robots and power, and then we'll check for questions. So this next slide is it's very busy, but it's got a lot of very good information on it. So let's start with the controller row. So you can see we've got the controllers start on the left with the KRC5 Micro, and then we have KRC5 S, M, and L, so small, medium, large. And these are all the same size boxes, but the difference is the size of the servo drives that are inside of it. So a KRC5S, for instance, small, is used for controlling smaller robots, medium for medium-sized robots, and large for large-sized robots. So thinking about that, if we look at the robots row and we look at the microcontroller, it controls all of the KUKA small robots, so the Scara, the Delta, the Agilus line, the LBR Easy, and one with the star here is the Cybertech Nano. So this is the robot. It's kind of sitting on the line between the Micro and the KRC5S. That's because that's the only robot model that can be controlled by either robot controller. And then if we move up, KRC5S, Cybertech, Nano, and Cybertech, both standard and the ARC versions. Note that the microcontroller it's not capable of controlling the ARC version of those systems. So ARC means it has a hollow wrist. That's good for arc welding wire to come up through. KRC5 medium, it's good for Iontech, Quantech robots, so 30 to 300 kilogram payload range. And then the KRC5L is for the Fortech and the large pelletizing robots. And the Titan, he's kind of special. He's got a few extra motors, so he actually requires a KRC5 large plus 2 additional drive boxes. So if you have a Titan robot, you need at least a triple cab for those modules. Okay, the cabinet row should be pretty self-explanatory. The micro cabinet goes with the microcontroller. Looking at the power in feed, so the micro 240 volt single phase input, and looking at the KRC5 standard, so that's dual, triple, quad basic cabs. Couple differences here. If your end customers have 3-phase Y power, that means they've got a grounded neutral with the building transformer. Then the cabinet will accept 380 to 480 volts. If they've got 3-phase delta power, or if you're shipping to someplace like Canada where they need 575 volts, or that's what they have, then you would need to have a KUKA transformer underneath the controller. One other option with respect to power for the dual, triple, and quad cabs. It has a 600 volt DC input. So this is available. Could be useful for mobile platforms that have DC power, not necessarily AC. All right. Austin, any questions at this point?
Nope, nothing yet. It was just referring to the audio at the very beginning, but other than that, we're good. We're good to still continue.
All right, we'll move on. Okay, multi-robot cabinets. So we touched on this with the micro cabinet. So it is possible to use the dual, triple, and quad cabs for this purpose, meaning you'll have multiple robot controller modules in a single cabinet. So in this example here, we've got a triple cab with 2 robot controller modules controlling 2 robots. So there are some limitations here. So if you don't need a KUKA transformer, meaning your customer's got 3-phase Y, you can have up to 3 medium or large size robot controllers in a cabinet. So you could be controlling 3 Quantec robots in a triple cab, for instance. You could also have up to 4 small controllers in a cabinet. So maybe you've got 4 arc welding Cybertech robots, being controlled with 1 cabinet. On the other hand, if your customer has Delta power and you need the KUKA transformer under there, the limit is 2 small controllers. So 2 Cybertech size robots. And that's just a power limitation of the current transformer. So we do have a new transformer in design, should be available in the future to accommodate more multi-robot cabinets. The other option here is, if you really are tight on space and you need a multi-robot cabinet, it is possible to provide a third-party transformer if your customer has a Delta. Okay, looking at a couple of the environmental characteristics. I think, as I said previously, the micro controller itself is IP20 rated, so it's really not suitable for dusty environments. If you've got that, you would want to put it inside an IP54 cabinet. So the micro cabinet provides that. The basic dual, triple, and quad are all IP54 as well. Temperature rating in general is -5 to 45 C. The basic cabinet is a little restricted at the low end there. And then with the dual, triple, and quad cabs, we have an optional cooling unit if you're going into a slightly hotter environment, so up to 55 Celsius. And so that's an option. Needs to be ordered with the cabinet. It's not able to be retrofitted right now just because it would require cutting a large hole in the ceiling of the existing cabinet. So it's not recommended. Okay, talking about external axes. So additional axes or external axes, these can be used to drive a positioner, linear track. Could be a KUKA positioner, it could be a custom positioner. So that's all possible. Looking at the microcontroller, it supports up to 4 additional axes. And so it has additional axis drive boxes, and each box is capable of up to 2 axes. So if you wanted to do 4 axes with a KRC5 microcontroller, you would need 2 additional drive boxes. And these are suitable for smaller motors. So the smaller motors of KUKA's selection there listed, because their servo drives are smaller. The micro cabinet, remember, it only has 2 spaces in it, so it only has enough space for 1 additional drive box. So if you're using the cabinet, you can get up to 2 additional axes, same motor set. When we look at the basic cabinet, so this is based on the KRC5 standard robot controller, there's really no additional space for any other drive boxes, but the robot controller module can be ordered with up to 1 additional axis. So you can have 1 40 amp drive inside the robot controller module. And then with the dual, triple, and quad, you can have up to 6 additional axes. Like the basic, the robot controller module itself can have a 40 amp drive in there. The additional drive box for the dual, triple, and quad, each box is capable of controlling up to 3 motors, 64 amp drives. That leads us into custom kinematics or custom robots. So sometimes you might come across an application where a standard robot commercially available just isn't going to fit the requirements for the application. Maybe you need to design your own robot. Maybe it's a gantry style. Maybe you need to design a special positioner, a large scale robot, something that it's not sold normally. You can do that. You can control that with the KRC5, and all the controllers and cabinets support that. The requirement is that the system must use KUKA motors. That's so we can control them. And then, obviously they should be sized appropriately. And then any kinematic design should be reviewed by KUKA engineering just to make sure that that design is supported as a kinematic solution. All right. UL certification. So we have our systems certified by a third party. We use TÜV, and they certify it to certain specs, standards. These are listed in our certificate. For example, UL 1740, RI 1506, CSA. They're listed here, as well as the models that comply with those standards. And these certificates are available. Since we're developing new product continuously, UL certification is ongoing. Right now, basic cab and cooling unit are going through UL certification as well. Likewise, for the micro, a separate certificate for that includes the micro cabinet with a list of certifications we comply with. Okay, any questions at this point?
Yep, we do have a couple. There was one that I think it was referring to a few slides ago, but it says, what if you have a 480 volt delta, but your customer has a 480 volt WIE or Y?
Yes. Yeah, so right. So if your customer's got Y and you've got delta, I mean, you can still use the KUKA transformer with the cabinet. It'll work with delta or Y. Otherwise, if you want to integrate at your facility and you've got delta, you can provide your own transformer and then ship the KUKA robot controller to the customer, obviously without that transformer.
Okay. Next question. What are the enclosed rating options? Do we have a NEMA 4X stainless steel enclosure option?
Okay. We don't have a stainless steel control or enclosure option. And I'm not sure about the rest of that question.
Alrighty. And then this one was another one too. It says, are cooling options available for all, I think he meant to try to say all like C5 controllers? Or is it only select?
Right, so the cooling option is only for the dual, triple, and quad cab. The basic, when I say cooling options, so that's the cooler that sits on top. Like the controllers themselves don't have cooling options, but the cabinets have internal cooling. And the basic cab had the additional cooling only for tight spaces. It did not increase the temperature range.
And one more just came in. When can we expect basic cab to be UL certified?
good question. I will try to get that answered before the end of this.
Alrighty, that was the last question for now.
Yep. All right. So let's move on to options. All right, so thinking about the KRC5 microcontroller, just standing by itself, it is possible to do safe operation with this, even though this controller does not support the safety I/O that is associated with it. So what it does is it allows you to do safe operation with a static configuration. So it would limit the functionality, but in many cases, it's still sufficient for the application. And we'll talk a little bit more about the details of what that means. But basically, in a nutshell, it's you cannot turn zones on and off dynamically, for instance, with safety sensors. But it is possible to do that, and that's with respect to discrete safe I/O. Again, we'll touch on this again. Drives ready lamp. This is available actually with every controller, and this is to satisfy the UL 1740 requirement. So a lamp that's on when motion is possible, and so KUKA can provide that. Customer can provide his own. The connection is at the controller. Talked about the 19-inch rack mount frame. The enabling switch, which connects to XG58. That's just a connection on the controller itself. So this allows a second person to be in the cell while you're in teach mode. So first person has the pendant, and he's going to use the enabling buttons on the pendant to enable drives to be able to move the robot. This enabling switch requires the second person that's in there to press and hold this as well. So both switches would have to be held, one by each person, for the robot to move. If either one is released, then the robot would stop. Other options for the microcontroller, a 24-volt supply. So this would be to drive the digital outputs that are included with the controller. And it's basically, it looks like a desktop supply. It just converts 120 to 24 volts DC. And it has the right connection on it, so you can just plug it directly into the microcontroller to provide that 24 volts. You can get the EtherCAT bridge. So this is for fail-safe over EtherCAT or functional safety over EtherCAT, sometimes interchange there. But that allows the micro to be an FSOE slave. And this is external hardware, so it does not fit inside the microcontroller. So it's something you'd have to mount somewhere. And the last thing specific to the microcontroller is an IP54 housing. So in case you didn't want the micro cabinet, this is just another option. It's just suited for dusty environments. Okay, so looking at options for all cabinets. So this is the micro, the basic dual, triple, and quad. The first one is the paint color. So shown there is the standard color with the rail 7035, the light gray or off-white door with a rail 7011 medium gray remainder of the cabinet. That's standard. You can get the whole thing 7035. And we offer a DB 703, which is a dark gray for the whole cabinet. And then for the dual, triple, quad, you can get those in rail 9003, typically for medical customers. Cabinet lock. So this is the door lock. We have several options there, but double bit T55. Typically for North America, most customers want the slotted, so that you can open it with this just a standard slotted screwdriver. Field bus. This is for all cabinets and the microcontroller as well. We support Ethernet IP, SIP safety, Profinet, and ProfiSafe. Those are just software options. EtherCAT FSOE requires that bridge module. It is some extra hardware, but allows FSOE. So for the cabinets, they do have front panel interfaces. And so these are connections at the front, and soft power button. It's always there as standard. There's a USB option, so that's useful if you need to take archives, backups, do restorations. You can do it without opening the door. The KUKA service interface, it's a network port on the front, allows you to connect a laptop to use work visual. The SmartPad connection, and then not shown in this picture would be the XG58 for the external enabling switch. You can get that there as well. Relatively new option, if you don't want the pendant connection at the front of the cabinet, we have an option to route that out the back of the cabinet, and you can use this panel mount device, so you can mount that connection. You can have that interface at your panel. More options that are available for all the cabinets: the external enabling switch, the drives ready lamp we talked about, quick swappable 60 gigabyte solid state drive. So this is actually part of the robot controller module, and it allows you to transfer that SSD from one controller to another very quickly. In the case your customer has very stringent production requirements, wants to absolutely minimize down production, in that case, they would probably have a spare robot controller module. And if theirs went down, they could quickly remove the one that's not working, take the SSD out of that one, put it in the spare, and put that spare back in the cabinet, connect it, and they would be up and running quickly. And the last one here, the USB recovery stick, that's been around for a long time now. It's for a full SSD image backup and restore. So it takes about 10 or 15 minutes to back up the whole hard drive or restore it. Looking at the micro cabinet, it's a little bit special because it provides additional functionality for the micro. So like we said earlier, if you had a microcontroller, you can use safe operation, but without safe I/O. So that means you can't turn on spaces on and off. But if you use the micro cabinet, you can gain that discrete safe I/O if you want it. So there's some space at the bottom of the cabinet for two what we call interface boards. The different interface boards we have are a digital I/O 16 in, 16 out board. Gives you this XG12 connection. We have a safety I/O XG11 complete that gives some additional safety signals. And then we have the XG11 plus the XG13. The XG13 provides the I/O for safe operation. So that's a combo of those two boards. So if you want the XG13, you have to have the XG11 complete. It's just a rule. But otherwise, you can pick and choose which two boards or up to two boards you want in that cabinet. Other options you can get in the cabinet are a network switch. We offer an 8-port. You can get additional back-off I/O, 24-volt supply. We call US1. That's just a 24 volts that comes on when the controller is turned on and goes off when the controller is turned off. It's a 5-amp circuit. We also have a US2 circuit, which is 24 volts that is switched on and off with robot drive power. So if the robot is e-stop, this 24-volt circuit would shut off as well. Other options for the micro rollers, cabinet spacers. So these are basically, think of them as wings that mount to the side of the controller to prevent it from being too close to other equipment. And that's for proper cooling. Okay, basic cabinet. Yes. Okay, so the UL certification, so I get to answer that question. It's expected early next year. So I believe the target month is January. So not a lot of options with the basic cabinet. You can get the interface boards, the digital I/O 1616, the full safety I/O, and the rear heat sink. Transformer is planned for this about a year from now. And at this point, no fork pockets and no rollers available with this cabinet. Looking at just the dual, triple, and quad cabinets, some options here. We talked about the transformer, the 600 volt DC input. There's an optional e-stop button for the front door. And yes, you can do all the discrete safe I/O. Rollers, fork pockets, and spacers. So these are all options. So looking at the picture here, you see the cabinet, first one with the standard base, and it's got the spacers. So these just prevent you from putting it too close to other equipment. Second one has the fork pockets instead of the standard base, and the last one, fork pockets with rollers. Second column is just the transformer, if you have the transformer underneath the cabinet with those options. Other options for the dual, triple, and quad: network switch, additional I/O, US1, US2, 24 volt circuits, the cooling unit. Okay. Any questions before we get into the safety options?
Yep, we got a few. First one is the enabling switch ordered separately, or is that included in price?
The enabling switch is ordered separately.
Okay. This one's a little bit of a two-part question. Can you elaborate on potential upgrade programs from KRC4 to KRC5 cabinets? Would this be hot swappable with program conversion tools available?
Okay. So typically, or in general, the KRC5 was meant to be a functional twin of the KRC4. So from your KRL programming perspective, programs migrate very well. There's no conversion that needs to be done. You just copy them on there and they basically run. One difference would be is if you have specific tech packages, like the KUKA tech packages that may have had changes from the version that was running on KRC4 versus the version that's running on KRC5. So there may be some subtle differences there. But in general, the transition is easy from a software perspective.
Okay. And how long will the KRC4 controllers be supported for with the introduction of KRC5?
KRC4 controllers are, as far as I know, being discontinued at the end of this year. So KRC5 will be, enforced beginning of next year.
Okay. Can you expand the back-off I/O?
So in general, yes. So with the KRC5 cabinet, the back-off I/O is on the device plate. And so there's a piece of DIN rail that's in there that the back-off I/O is sitting on. There's 24 volts that goes to the coupler, and if you're expanding the I/O, you would want to check if you need to expand the 24 volt supply, especially if you're driving, higher amp outputs, things like that. You'd have to take the power requirements into consideration. But in general, for whatever DIN rail space is in there, you could expand that. And from that perspective, it's just a matter of configuring the I/O and work visual.
Okay. Couple more. Could you explain the KLI port location on the cabinet and the various options that come with it? So IT versus OT.
Okay, I'll do my best. So on the robot controller module, the KLI port standard is the XF5. So there are 8 network ports on the robot controller module. So the 5th one is the KLI. There are also, that can be used for, basic communication. You can use it for work visual. You can use it for Ethernet IP, Profinet, Ethernet KRL. So you can use it for all of those things. There is a KLI IT option and a KLI OT option. And I believe OT stands for operational and IT for your standard IT stuff. And going from memory here, the OT is used for things like vision systems, anything on the cell network, if you will. So anything that's contained to the robot cell that you don't necessarily want accessing your company LAN. The KLI IT is specifically for that, so that you can connect to your company LAN, and it would restrict it restricts the network traffic to it, so it's not interfering with your cell network traffic. Hopefully that's okay for an answer. Certainly we could spend a lot of time on that. Any more questions, Austin?
Yep, there is 2 more. Can you explain the SSD swap process one more time?
Sure. So I mean, in a nutshell, the SSD is just the drive for the controller computer. To remove it and insert it, you just have to make sure that the controller power is off. And then you do have to open the cabinet door, and right there visible, I don't think I have a picture handy, but is the SSD is right at the front. So there's a little lever that you slide to the side, and you can then eject the SSD, and you just pull it out. So if you want to transfer that to a different controller, you can do it just the reverse process. Hopefully that's clear.
Yep. And then the last one, KRC4 is discontinued, but still supported, correct?
Yeah. KRC4 will be supported for years, as far as you won't be able to order it after December of this year, but we'll have spare parts and
Okay, perfect. I think we're all good with questions for now. If you want to continue.
Okay. All right, moving on to the safety options. Okay. So what I call basic safety is included with every controller. So this just provides the ability to use safe IO for some safe devices, things like an external e-stop, a safety gate, so a gate switch, on your fence that allows you to walk in there and use the pendant in T1, but if you're in auto mode, it does not allow drives to come on. The external enable, we talked about the external enabling switch for a second person in the cell in teach mode. The local e-stop on the panel. These are all basic safety features. Additionally, there's a safe operational stop. So this is when the robot servos are still on, but there might be some human robot collaboration going on. So the robot's not allowed to move, but it's not e-stopped either. That's what the safe operational stop is for. We also have a safety stop 1 and 2, and these both cause a controlled on-path stop. Safety stop 1 differs in that it disables drives after the robot comes to a stop. Safety stop 2 enables standstill monitoring, like the safe operational stop after it stops. So these are all included with every controller, especially if you're using field bus safety. There are some one limitation with the microcontroller. So if you have just the microcontroller, you're using the discrete safe IO, then you wouldn't have access to these last three, the safe operational stop or the safety stops 1 and 2. With all of the other controllers, these are available as options. Some of the safety options that KUKA has, safe range monitoring. This is basically safety rated access limits. So soft limits are not safety rated, obviously, but safe range monitoring would provide that at a safety level. Safe single break. This is when very useful if you have a positioner that is has two sides to it. So the robot would be working on one side while a human is unloading and loading parts on the other side. So certainly whenever the human is doing his operation at the table, that positioner, you don't want that positioner to move. So safe single break is the feature that would prevent that motion. And typically you would have an area scanner or a light curtain or some safety device to detect that human presence, and that would trigger this safe single break functionality so the robot can keep doing its thing without any harm to the operator. We also have safe velocity monitoring, so you can enforce a reduced velocity for the program. So very useful for some situations where there might be some human proximity. In addition to that, we have safe operation, which includes the functionality of all three of those, as well as additional features, including Cartesian cell area. So you can define a cell zone that the robot's not allowed to move beyond. You can define 16 Cartesian or axis spaces, if you will. They can be defined as protected, meaning the robot cannot enter them, or you can define those as workspaces, meaning the robot could not leave them. You can model the tooling with spheres, and we allow up to 16 different tools. You can do reduced velocity enforcement inside those spaces, if that's what you want. And you can also enable what we call braking before restricted areas. So prevent the robot from breaching the space. So typically a protected space, if the robot violates that space, then it stops. With the braking before restricted areas, that means if the safety system believes that the space is going to be violated, it will stop it before it is. So these four, safe operation, safe range monitoring, single break, they're all safe options. And this slide just shows a chart of the different features and then which option encapsulates those features. It's a good reference slide. So when we talk about interfacing with these different options, basic safety and the safe operation monitoring, single break, etc. You can interface through safe IO. So with the basic safety, there's 2 bytes of IO available. With the extended safety, there's another 6 bytes. And if you're using field bus safety, ProfiSafe, SIP safety over Ethernet IP, or failsafe over EtherCAT, all from your safety PLC, which is the safety master. You have access to all these signals for all that safety control. The only IO that is not on the field bus would be the external enable for the external enabling switch, and the local e-stop, which is for the e-stop mounted to the cabinet door. Those are always on a discrete safe IO, which is the XG58. So again, if you're using field bus safety, you have access to all the IO. full functionality of the safe options. If you don't have a safety PLC, or you don't want to use safety on a field bus, you can use the discrete safe IO, and that comes on different connectors for the robot controllers. So specifically, externally stop operator safety, those are on the XG11.1. So that comes with every robot controller. Likewise, XG58, every robot controller. The optional ones are the XG11.3, which has the safe operational stop, safety stops 1 and 2, and then the XG13, which is the interface for the safety options. So with the microcontroller that's without the cabinet, you can only have XG11.1 and XG58. So that's why you lose the ability to turn on and off those protected spaces with safe operation. So it would not be practical to have an area scanner that's detecting human presence to enable a zone. So you could not do that with the microcontroller by itself with discrete IO as your safety. If you've got field bus safety, you can do that. If you need that functionality with the microcontroller, then you'd want to go with the micro cabinet so that you can have that XG11.3 and XG13. And then lastly, just a chart here showing which robots are included with the different safety options. So basically, all the robots from the Agilist through Titan, so the Agilist 6 kilogram payload on up to Titan will support all 4 safe options. The KR4 Agilist and the SCARA, you can use safe velocity monitoring with them, but not the range monitoring, safe operation, or safe single brake. And the Delta doesn't really support any of those safety options. And that's mainly due to the speed of the robot itself. Some of these small robots move so fast that by the time you detected a safety violation, the stopping distance is going to be quite large. And then if you are using the KRC5 for a custom robot, just note that the safe options are not compatible with custom robots because they're specialized to deal with stopping distances, stopping times of KUKA robots. All right, and that's the end of the presentation. Austin, are there any more questions?
Yep, there is one more question. There's a couple parts to it. So is there a new KSS released for these controllers?
Yes, sorry, I should have said that when moving from KRC4 to KRC5. KRC5 uses KUKA system software 8.7.
And then also with, is there a new version of Work Visual required?
I would recommend always using the latest version of Work Visual. I don't remember what version first supported KRC5, but it is freely downloadable at KUKA.com. And then if you go to services and downloads, but it's Work Visual 6 that works for both KRC5 and KRC4.
Okay. And will new Rockwell AOPs be released?
Good question. For the KRC5, there are EDS files that I believe are compatible with Rockwell. I don't think you need the AOP.
Alrighty. I think that is it for questions as of now. So I think that'll conclude the webinar. Thank you everyone today for joining today's webinar. This live recording will be live on YouTube and on our website in about 2 weeks. And then I'm going to send a follow-up email when it is live on our website and on YouTube. So thank you again, everyone. Thank you, Mike.
All right, thank you.
Industrial intelligence.